Welcome to Algeomulus Prep Academy, your center for all things algebra, geometry, and calculus. Today we'll be learning a calculus lesson. Integration by dividing an improper rational function. For our first example, we'll be integrating the following function. Integral of 3x cubed plus 9x squared minus 4x plus 20 all over x plus 10 dx. To simplify this function, we'll need to use long division. For a refresher, the way long division works is you see how many times the divisor can fit into the dividend. For example, this first one, x goes into 3x cubed 3x squared times. You then multiply that through, subtract, and continue, similar to how you do long division with whole numbers. Doing long division in this manner gives us a final result of 3x squared minus 21x plus 206 minus 2040 over x plus 10. Now that we've used long division, we're able to rewrite this function in a manner such that we can integrate. This new function now is 3x squared minus 21x plus 206 minus 2040 over x plus 10 dx. The function is now in a form where we can use the power rule of integration. The power rule of integration is adding 1 to the power and dividing by the power. However, for the last term, we'll need to use the ln rule of integration, where the integral of 1 over x dx is ln of the absolute value of x. After using the power rule of integration, we're able to simplify and get our final result, which is x cubed minus 21 over 2x squared plus 206x minus 2040 times the ln of the absolute value of x plus 10 plus c.
Alright, for example 2, we have the integral from 0 to 1 of 2x to the third plus 4x squared minus 2x minus 5 divided by x squared plus x minus 3. So again, we're going to do long division, see how many times the divisor goes into the dividend, multiply through, subtract, and bring down a term until we get a remainder that can no longer be divided into. This gives us 2x plus 2 plus 2x plus 1 divided by x squared plus x minus 3. And now we could rewrite the integral. Alright, moving on, we have the integral from 0 to 1 of 2x plus 2 plus 2x plus 1 divided by x squared plus x minus 3 dx. We're going to use u substitution with u being x squared plus x minus 3 and du being 2x plus 1 dx. We could make two separate integrals, plug the u into the remainder, which allows us to use the power rule and the natural log rule of integration. This allows us to integrate, and then we could plug back in the u, giving us x squared plus 2x plus ln of x squared plus x minus 3 from 0 to 1. Now we could use the fundamental theorem of calculus to plug in 0 and 1 into the integrated function. This gives us 3 plus ln of negative 1 minus ln of negative 3, which evaluates to 3 minus ln of 3, which is 1.901.
For our final example, we'll be integrating the following. The integral of x cubed minus 17x squared plus 150 over x plus 4 dx. We can simplify this through long division. However, since there's no singular x term, we'll need to use the 0x as a placeholder. We'll use the same process as before. X goes into x cubed x squared times x plus 4 is x cubed plus 4x squared. We subtract that, bring down a term, and repeat the process until we're left with a final answer. In this case, our final answer is x squared minus 21x plus 84 with the remainder of negative 186 over x plus 4. Now that we've done long division, our original function can be rewritten as a new function that is equivalent but is able to be integrated easily. We'll be using the power rule of integration and the ln rule of integration. First, we'll spread out this integral using the properties of integrals. Using the power rule on the first three terms is add 1 to the power and divide by the power, but we need to use some different techniques for the last term. For the last term, we'll first pull out the constant of negative 186, then say u equal to x plus 4 and du equal to dx. This allows us to rewrite the integral as 1 over u du, which is equivalent to the ln of the absolute value of u. Plugging the u back in gives us negative 186 times the ln of the absolute value of x plus 4 plus c. Now that we've finished integrating, our original function, which was x cubed minus 17x squared plus 150 all over x plus 4 dx, is now equivalent to x cubed over 3 minus 21x squared over 2 plus 84x minus 186 times the ln of the absolute value of x plus 4 plus c. Thanks for watching, everyone. We'll see you next time.